Hello everyone, welcome back to our YouTube channel. In this video, we are going to create an end-to-end project of SMS spam and non-spam classification and also going to deploy it. Okay, so again, if you are looking for the best projects which can add value to your resume, then you are at the right place. So stay tuned at the end of this video. So we'll have in-depth understanding of how to create a SMS spam and non-spam classifier with the help of NLP techniques, and we are going to explore different models which can build the best classifier and also going to deploy this SMS spam and non-spam classifier. And again, lastly, we create an user interface with the help of Streamlit. So firstly, let's understand what are the steps that we are going to perform. So for SMS spam and non-spam classification, firstly we import all the required Python libraries. Again, we perform data cleaning. So I'm going to use this dataset, SMS spam and non-spam collection dataset. I will provide a link of this dataset in the description, so you can able to access this. So it's having two main columns. First is ham and spam, which is classifying this message, which in the column 2 to a ham and spam. Ham is nothing but non-spam. Okay, so it is going to classify the particular message into spam and non-spam. Now let's move on to the project part. Okay, so we are going to also perform explore data analysis. So we are going to understand the meaningful insights from our data. Again, we are going to build a model, a classifier model, which can classify the particular message into spam and non-spam. So we are going to perform different models. We are going to create different models. So, and we will take best model out of this, which having higher accuracy, and we are going to deploy this with the help of some backend API, and again going to create an user interface with the help of Streamlit. We are going to deploy Streamlit application, our application with the help of Streamlit, and again going to create an user interface with the help of Streamlit. Now let's start with importing all the required libraries. Firstly, we import pandas because we required this to fetch our CSV file into Python. Import pandas as PD. Again, from analytic dot corpus, we are going to import stopwords. Import stopwords, and from analytic again, analytic dot stream, we are going to import porter streamer because we required this file performing streaming on our words actually. So again, from analytic dot tokenize, we are going to import word underscore tokenize. So these are the required libraries. Maybe we required more libraries while we are going ahead to deploy our application. We are going to create a model. Okay, these are the basic libraries that we required. So I am going to import this. So we have imported all the libraries. Again, going to import our data set. Pandas pd dot read underscore csv. So I have already copied my CSV file, spam.csv. Here you can see this is our CSV file though. So my file is in this same directory. So that's why I can able to access it directly with the name spam.csv. So let's run this. Okay, it's UTF-8 codec can't decode bytes in position. So we have to change the encoding, right? So for encoding, I am going to pass this argument encoding equals to Latin hyphen 1. Okay. So I think our data is loaded. So let's see our data set. So this is our data set. Actually, from our data set, we can able to see we require only two columns. So V1 and V2. This unnamed 2, unnamed 3 and unnamed 4 contains only nan values. So if you wanted to know about this, we can go like uh, data dot info. Okay, so you can having 50 non-null values, and okay, and unnamed 3 having 12 non-null values, and unnamed 4 having 6. But I think it does not add any value to our ML model. So let's remove this column first of all, because it does not add much value to our model. So for removing, we are going to use data.drop, and we are going to uh, remove these three columns. So I'm going to copy this name, unnamed 2, unnamed 3. Again, the second column is unnamed 3, unnamed 3. Let's make it 3. Again, uh, unnamed 4. Okay, make it 4. So let's run this. Okay, okay. There is some mistake of space. I think I have to make it less, because I have copied it, so it might not have. Okay, this is the problem. We have to remove the space. Okay, this is an extra space not found in axis. Okay, uh, the data does not able to find this name on the axis. Okay, we have to define axis as well. Oh, so it's my bad. Axis equals to 1, because it going to find this particular columns in the column part. Okay, so we have to define our axis. That is my mistake. Okay, so data dot head. So let's run this. uh, Axis equals to 1, and I think data should be okay. New data equals to data drop. Okay, now our data set does not contain unnamed 2, unnamed 3, unnamed 4 column. uh, Again, we are going to rename this v1 and v2. Let's rename uh, data dot rename v1 as a columns equals to define a dict v1 equals let's name it as a label, and v2 as a message. Okay, v2 as a message. Okay, we have renamed now. Okay, now let's load again our dataset. Okay, we have to provide data equals to. Okay, now our column name of is getting changed. First column is our label, second column is our message that we are going to use to classify spam and non-spam. Okay, now let's check is there any null value present in label or message column. So for that I'm going to check with is null. So we have to take sum of this dot sum. Okay, so label column does not, or label or message, both the columns does not contain any null value. Okay, so now let's move on to the exploratory data analysis part. Okay, so let's mark down EDA. Okay, it's an exploratory data analysis. Exploratory data analysis. Okay, let's create a code. Have to. Okay, let's remove this markdown part. For exploratory data analysis or EDA part, we import matplotlib, the basic library. Matplotlib dot pyplot as PLT, and the second library is SNS library, Cbound library. Sorry, import Cbound as SNS. If you does not have these packages installed on your system, then you can install it like pip install and your package name. Here I can provide the Cbound. I have already installed, so it says the okay Cbound. Uh, it will say requirement already satisfied. So you can install any packages with the help of this pip install command. Okay. Now, as we have one column, one categorical column, which is label. So let's check the distribution of ham and non-spam ham or spam category. Okay. So how many messages belong to the ham class or how many messages belong to the spam class? Uh, for that, we are going to create a count plot. So first of all, let's check the count. For that, I am going to use the pandas operation. Data of uh, data of label. Sorry, data of label. Mm, label equals to ham. Okay, so we have 408 4,825 entries in a ham category, and for spam it would be 747. Okay, so you can see the number of messages belong to the ham part is quite higher as compared to the spam. So let's create a count plot. Let's visualize this. For that, I'm going to use plt dot fig size. We are going to define figure size first of all. So let's define this as a mm, it's not, I think it's not a figure size. You have to define first figure, then inside that we have to define fig size. Fig size would be 8:6, and with the help of SNS we are going to create a count plot. Okay, count plot, in that we have to provide your label column x equals to a label, and again you have to provide your data equals to data. Now let's give the title to our graph, plt dot title, which is like distribution of spam and non-spam SMS. Distribution, actually there is a mistake. Distribution, distribution. Okay, now label your x-axis, x label. It's a label, and on the y-axis we have count. Y label, we have count. Okay, now let's show our graph, plt.show. So let's run this. Here you can see the ham class category contains higher messages as compared to the spam. Now let's add another column. Let's see the how many characters present in the ham messages, or how many characters present or length of characters in the spam SMS. Okay, for that I'm going to create another column, that is data of SMS underscore length, which equals to data of message. I am going to perform a operation, dot apply operation. It's an inbuilt Python operation. So I'm going to apply length operation on the all the entries present in the message column. Okay, so here you can see there is new column, data head, new column added in our data, that is SMS length. Let's print the first message so you can able to see. Okay, so this is first message having 11 111 characters. Second SMS having 29 characters. So let's see the is that ham message having higher number of characters or spam SMS having higher number of characters. Let's see the distribution, or let's see the graphical visualization of how many is that ham having higher characters or spam. Okay, for that we are going to uh, create it with the help of PLT as well as Seaborn package. For that I'm going to copy. I have already created the basic structure, so I am just copied that particular structure. So figure size will be same. We are going to replace count plot with the hist plot. Okay, hist plot, we have to pass hue equals to our label, and another part is bins equals to, let's say, 50, and we are going to create a kernel density estimation graph. So let's say KD equals to true. Okay, so distribution of character lengths, we can say distribution of character lengths in spam and non-spam. SMS length, okay, in spam and non-spam SMS. X label is our we can say email length, email or SMS length, sorry, SMS length, and on the y-axis we can say count. Okay, so I think we have to pass x as a, because it's again created the bar graph of the label part, so we have to pass here SMS underscore length, SMS underscore length column. Now you can see here the number of characters present in a ham messages is quite higher as compared to the spam. Here you can see in the orange part the spam SMS having low number of characters. Here you can see this, in this part, and the density estimation of number of ham characters is quite high as compared to the density estimation of spam. Here you can see the density estimation graph of ham is having higher peak as compared to the spam. So that's why you can say that the number of characters present in the ham SMS is quite high as compared to spam SMS. Okay, you can also create a box plot to see the number of which having higher characters. So it's an optional, so if you want to check it with box plot, all the remaining part is same. No, I have to remove some part. We have to provide x and y axis part. Okay, so I have to provide here y equals to SMS, x is equals to label, actually x is label part, label, and y is actually y is equals to SMS underscore length. There is an unnecessary part here. Okay, so you can see the range of number of characters of ham is higher. It's going around 800, 0 to 800, and the spam is around 230 or 250, 0 to 230 or 250. So from this you can able to understand the number of characters present in this ham is quite higher. Let's move on to the very important part of our project, that is text preprocessing. Basically, any machine learning model build upon a data, but data should be clean. So in case of NLP, data cleaning is very important. That is text preprocessing. So let's mark down it. Let's write here text preprocessing. Pre-processing. Okay. How to count code. Okay. Okay. Sorry, Monish. Uh, for text preprocessing, first of all, we remove the HTML tags if there any HTML tag present in our text message, and that which is not good or which is not add any value to our model. So that's why let's firstly define a function which remove the HTML tags. Remove HTML tags. So in this we have to pass our message or token. Okay, so I will write text. Okay. So for this function we need to import one package, that is RE. RE is nothing but regular expression package, which is regex. Okay, so import RE. RE stands for regular expression. Okay, so clean text equals to RE dot substitute. Sub means substitute. So we have to write like uh, a string. We have to this is the open bracket. In case of HTML tags, this is called as open bracket. So we don't want any open bracket at the starting of the text. That's why we added it here. So again, the second thing is if there is any close bracket lies in the string, in that case we have write this. Okay, we have to write this. Lastly, we have to remove the close bracket as well. So we have to substitute this with the empty space. Okay, and how to pass text. Okay, this is our function. This will return us a clean text. Clean underscore text. So let's apply this on our data. For that, data of uh, I will say data of message our column message equals to data of message. Apply is very important Python function which will helpful to apply any function to the all entries of our column. Okay, so message dot apply remove underscore html tags. Okay, so again let's run this. Okay, it is successfully executed. Okay, let's print our data dot head. I think the data does not contain any HTML tag, so that's why but maybe is there is somewhere any HTML tag is present, it get also removed. So I will explain this one. Okay, so this is the open bracket and this is the close bracket, which is specifically called in a HTML part. So we have to write this because if any string started with a opening bracket, then meanwhile in the middle part if there is a string contains any close bracket, and if the any string ended with a close bracket is getting replaced with the empty string. Okay, so we are going to remove all these string which matches this format. Okay, if any string which match this kind of structure, then we replace or substitute with this empty space. So we have to pass text here. So we have already executed this. Now the second thing is we are going to tokenize our text. Okay. For that, I am going to define a function, tokenize underscore text. Okay. You have to pass a text tokens equals to word underscore tokenize, and here I have to pass text and again return the tokens. Okay, this is our function. But before that, let's check is that we have imported our word tokenize, or yeah, here you can see I have already imported word underscore tokenize. Okay, so let's apply this also on the message column. Apply this function. Okay, date of message equals to date of message dot apply, and we have to pass this function because this function getting applied on all the entries within the message column. So all the text getting converted into a tokens. So tokenize underscore text. So let's run this. Okay. Uh, there is an error. Okay. I think output is truncated. Okay. I think we have to download our NLTK repo. So we haven't downloaded it. So that's why this is the issue. So let's for that we have to write NLTK dot download. I have to pass PUNKT, which is the actually a we can say a model which is already in the NLTK data repo, which will helpful to tokenize the text. Okay, so let's I think import NLTK. I have already imported, but uh, let's okay. First of all, I will import it again. Okay, import NLTK. Now run this. Okay, now you can see our code is successfully executed. Date of head. Okay, you can see our message column now consists of all the tokens, text tokens. Date of message of let's say 0th entry. Okay, so here you can see we have all our text converted into our tokens. So also you can see there are some uh, special characters also, so which is not adding any value. So our next step is removing the uh, special characters. Okay, so you can see this is the comma, or these are the like say dots, which does not add any value, so that's why I have to remove this. So for this I am going to define a function remove underscore special characters plus, and to pass uh, tokens. Okay, so clean underscore tokens equals to I'm to write a forward for word in tokens. If word is any alphanumeric number, then only it will get added into the list. Okay, word dot l is alphanumeric. Okay, is l num. Okay, so I have to write like this. So our clean tokens contain only the text and the numbers, does not contain any special characters. Okay, so after that you can see this dots and this comma also get removed. Okay, return clean tokens. Okay, return clean tokens. Okay, so let's apply this on our message column. Date of message equals to date of, okay, message dot apply, remove special characters. Okay, so let's run this. Okay, name tokens is not defined. Where is the tokens? Okay, okay, tokens. Okay, now our function is properly executed. Date of message, let's set 0. You can see it does not contain any comma or any dots like here. The last element as consist of dots. Now the last element is VAT. So this is the last element. So we have removed the special characters, which does not add any value to our model. So this is a very important crucial part, because due to this your model get like it will perform worst, it will not work well. So that's why you have to remove the special characters which does not add any value to your model. Okay, now the next part is removing stop words. Stop words like in, as, these are the stop words which does not add any value, so we have to remove this. So for stop words, stop words equals to stop words equals to, let's get the unique stop words. Stop words dot words English. So let's run this. Okay, I think we have to download the stopwords repo or stopwords data from the NLTK package. For that I have to do one thing. NLTK dot download, because it is saying it does not getting any stop words, trying to attempt to load stop words but does not get stopword.zip file. So that's why there is an issue. So NLTK dot download, we have to write stop words. So let's run this. It's properly executed. Okay, stop words method object is not callable. Okay, so stop words method object is not callable. Think there is a mistake. Okay, let's run this again. Still it's having an issue. Method object is not callable. I didn't get it. What is this? Stop underscore words. Let's run this. I think there is a my mistake. So let's run this. Okay. So I have to write a close bracket, not the X square bracket, normal close bracket. Let's run this. Okay. Let's print all the stop words so you can get what is the stop words. Stop underscore words. Okay. Let's write it stop words. It will make more sense. Okay. Stop words. These are the stop words. Let's print it with separated by. Okay. We'll get these are the stop words. Then, now, are, no, add. So this is the stopwatch. Here you can see it's a big list. So wouldn't again. These are the stopwatch, which does not add any value to our model. That's why it does not getting considered in a sentiment analysis model or any classification based model in a text or NLP part. So removing the stop words from our text is very important or crucial part of our text pre-processing. So let's define a function that will pre-process our text and remove all the stop words. So let's define a function remove underscore stop words. So I have to pass the tokens. Okay. So filtered words equals to, let's apply the follow word for word in tokens. If word not in stop words. Okay, so I have to return this filtered words. Return this filtered underscore words. Okay, so we are going to perform a list comprehension operation. Like you can see, word for word in tokens if that particular word does not belong to the stop word list. Okay, so it will return only those words which does not belongs to the stop words. Okay, so let's apply this on message column. Date of message equals to date of message dot apply remove underscore stop words. Okay, but before executing this, let's understand how many stop words present in our text. Let's understand what is how many numbers of stop words present in our first message. So let's check it. Stop word count equals to length of for word for word in the first message, that is date of message of 0. Okay, we are going to check how many stop words present in our first message of our message column. If word in stop words. Okay, let's print this stop words count, copy it. Okay, print it. Okay, here you can see we have 4 stop words present in our first message. If you wanted to know what are these stop words, then you can check like this. So these are the stop words, not the count. So let's change this name. So this is the stop word. So until only in there, these are the stop words which does not add any value to our model. These are only from the first message. There are many other stop words present also in the remaining message. So let's apply this remove underscore stop words function to all the entries within the message column. Okay, so let's run this. Okay, name filtered underscore words is not defined. Okay, this is the mistake, filtered. Okay, now let's run this. Again, let's check our stop words getting removed or not. Okay, we have 0 stop words in the first message. That's why we can say our all the stop words present in our messages is getting clean or getting removed. So we have now our clean text. Now the next step is stemming, which is also an important step. We are going to stem the word, we can say, uh, there are many words like killing or nothing. Also, they having some stem words, like that is root word. We are going to retrieve these root words from uh, the word given in the message. Okay. So first of all, for this, let's import a porter streamer. So st equals to porter streamer. Okay, we have to pass here bracket. Okay. Okay. So define a function stem underscore words equals to okay. I have to pass the tokens stem underscore words equals to st dot stem the word for word in tokens. Okay. Okay, and return this stem words stem underscore words. Okay, so now let's apply this stem words function to all the entries within the message column. So data of message equals to data of message dot apply stem underscore words. So let's run this. Now we have our clean text with this stemming part also. So data of message, data of, let's say, check head. So let's run this. Now we have our clean text. Okay, so these are the all the pre-processing steps that we have performed. Firstly, let's check what we did actually. So firstly, we remove all the HTML tags. Again, we have tokenized our the text into our words. Then we perform removing the special characters. Again, we are removing the stop words also. Here you can see we have removed the stop words because it does not add any value. And lastly, we stemming the all words present in our messages or present in our tokens. Okay, so these are the basic or important steps we have to perform in our text pre-processing while building any sentiment analysis model. Here we are going to build a classification model, that is email or message or SMS classification model. Is it a spam or ham? Okay, so these are the basic text pre-processing steps you have to perform in any text based while building any text based model. Okay, so these are the very basic steps. So lastly, we have to join these tokens within the message. Okay, we have to build or we have to create a clean message. So we are not going to pass one by one token to our model, so that's why we have to combine this text. So for that, data of message equals to data of message dot apply. We have to apply lambda function. Okay, lambda function x equals to, we are going to apply join operation on this. Okay, so join with some space. Okay, join, let's map the string with X, and we are also going to convert this string into a lower alphabets. Okay, so let's convert it into a lower alphabets. Lower. Okay, so let's run this. Okay, invalid. Okay, I think it should not be an invalid syntax. Okay, okay, here dot is missing. Okay. Now let's see date of message column. So you can see this is our clean text or date of dot my head data dot head. Let's see data dot head. Here you can see our tokens getting combined or joined. So we'll have a clean message. It does not contain any stop word. We have also stemming the words, and we have also removed these special characters or unnecessary part from our message. So let's print the 0th message. So we'll get an idea. Message 0. So you can see this is our clean text. This is the text that we are going to pass to our model. So on this clean text, we are going to build a SMS classifier between spam and ham. So these are the basic steps required to build a classifier. Now let's move on to the model building part. So let's mark down here model building. Okay. So for creating a model, we required some libraries. So let's import some basic libraries that we required from sklearn dot model underscore selection import train test split. The second is from sklearn dot matrix import accuracy score and again classification report. Third is from sklearn sklearn dot feature extraction dot text import tfid factorizer. This tfid factorizer is quite useful to convert textual data into a numerical format. tfid factorizer. Let's run this. Okay, now let's split our data set into a train and test part. So we have two columns which are quite important. First is message column and second is label. So x equals to date of message and our target variable y is date of label. Okay. Now let's pass. First of all, let's uh, convert our textual data into a numerical format. Then we'll split into a training and testing part. Okay. So factorizer equals to tfid of factorizer, and here I'm going to pass our message column x capital X equals to factorizer dot fit underscore transform. Here I have to pass data of message. So this is our textual data will get converted into a numerical data. So now let's split it into a train and test part. So x underscore train comma x underscore test comma y underscore train comma y underscore test equals to train test split. We have to pass the x, that is this x, into this first argument. Second is y. This is the label column. Okay, we have to pass this into as a y, that is target variable. So third argument is test underscore size equals to 0.2. So ideally 80% data is in training set and 20% data is in testing set. Okay, and last argument is random state, which equals to, let's say, 40. So let's run this. Now let's train our model. We'll train different models on our training set and we'll check accuracy on the testing set, and which having higher accuracy, I will choose that model as a final model. Okay, so first let's go with support vector classifier. Support vector classifier. Okay, for that I have to import sklearn dot svm from sklearn.svm. From sklearn.svm I have to import svc. Okay, svc. Okay, so let's build the model. So sv underscore model equals to svc. We have to pass, let's first of all we have to load, then we have to pass the, we have to feed this model to our data. So okay, sv underscore model dot fit to x underscore train and y underscore train. Okay, let's run this. Okay, could not convert string to float. I think that is not the mistake. I have to pass this capital X, that is numerical data, into the trend test plate. Okay, now we have proper uh, data, because I have already passed this data, that is textual data, to the trend test split part. That's why the X trend contains text. So that's why our SVC model does not uh, able to capture this input. Okay, so that's why here it has is said this is the text which is coming towards as an input to the model, so it's not able to convert the string to the float. So this is saying that. Okay, now you can see x underscore train is in the number form. Okay, let's print. Okay, this is in the number form, and also y underscore train is also in the number form. Okay, now let's run this. Model training process is going on. Okay, we have completed our model training process. Now let's see the accuracy of our support vector classifier model. So for that, let's perform model prediction. Model prediction y underscore pred equals to sv underscore model dot predict x underscore test. Okay, so now after that, let's check the accuracy. So accuracy equals to accuracy underscore score, and we have to pass y underscore test comma y underscore pred. Okay, so y underscore test is the actual labels, y underscore pred is the predicted labels. And again we are going to, let's print this accuracy score. Print this accuracy score equals to, let's say, accuracy. Okay. Again, we are going to print the classification report. Here we are also going to pass y underscore test, comma y underscore pred. Okay, let's run this. Here we can see we have accuracy score about 0.97, which is quite good. And also in the classification report, we have good precision and recall. Also, you can see the F1 score is also good. So support vector classifier performing well on our data set. Now let's move on to the another model, that is the random forest classifier. So another model is random forest classifier. Okay. So for that, I have to import from, okay, from sklearn, dot ensemble import random forest classifier. Okay, now let's create a model, random forest model. Rm model equals to random forest classifier, or to load the classifier. I am going to write n estimators equals to 100 and random state equals to 30. Okay, uh, let's fit our model dot fit model dot rm underscore model dot fit. Here also we have to pass x underscore train and y underscore train. Okay, here we have mentioned n estimators is the parameter for random forest classifier. So these are the number of, we can say, trees or decision trees random forest classifier use for their estimation. And random state 30 is the another parameter we have to pass into the random forest classifier. Okay, so random state is for, like, we are not, if we run this cell again for the next time, we'll get the same result. Okay, so that's why we have to pass random state equals to 30. Okay, let's say let's run this actually. Model training takes little bit amount of time. Okay, our model training is done. Now let's perform prediction. Y underscore pred 1, because we have already used y underscore pred, but it getting override, but let it be. We'll say y underscore pred 1 equals to rm underscore model dot predict x underscore test, and again we are going to return an accuracy score. So let's copy it and paste it here. Just we have to pass y underscore pred 1. Okay, here also we have to pass y underscore pred 1. So let's, I think it's okay. Let's run this. Here we can see we have again around 97% accuracy. F1 score is 0.99, 0.91 for class 1. So here let's compare the F1 score. F1 score is around same, but there is little bit difference in the recall for the random forest for class 1 is here 0.83, and in case of support vector classifier it is 0.84, and the remaining part is in the precision part. For class 1 the precision of random forest is 0.97, and for support vector classifier it's 0.98. So let's build another classifier, which is logistic regression. So let's build logistic regression. Okay, regression. Okay. So for that I have to import from sklearn dot linear underscore model
import logistic regression. Okay, again we are going to perform, let's create a model, logistic regression model, LR model equals to logistic regression. Let's load this, and now we are going to fit this LR underscore model on our data. X underscore train comma y underscore train. So let's run this. Our model is uh, ready to ready for prediction actually. So let's perform prediction. Y underscore pred 3 equals to LR underscore model. We have to pass X underscore test inside this, and the remaining part is same. So we have to just change one argument, which is y pred 1. We have to pass, let's say y pred 3 here, y pred 2. Okay, so here I have to pass 2, here again we have to pass 2. Now let's run this. uh, Logistic regression is object is not callable. Okay, let's run this again. So LR underscore model X underscore test. The predict part is missing. Model dot predict. Okay, so let's run this. Here you can see the accuracy score is around 0.96, and the F1 score for class 0 is 0.98, but for class 1 it is quite low as compared to the random forest and support vector classifier. Here you can see for support vector classifier it is 0.91. For again random forest it is also 0.91, but in case of logistic regression it is 0.83. So we can choose the best out of it. The best model, I think it is maybe a random forest. We can take it as a good model, or we can also choose support vector classifier. Now let's take one of this model. I'm going to take a random forest as our final model. Now we are going to save this model with the help of pickle. So for that I am going to import pickle. So with open, let's name it as a rm underscore model dot pkl. Okay, I have to pass wb. It's a bytes, the format, byte format, as model underscore file. We have to dump as pickle dot dump the rm underscore model, rm underscore model as a model file. Okay, so let's run this. Here you can see we have rm underscore pickle file. This is our model. This part you can see this is our final model. Okay, let's create another file in which we are going to build our API endpoint. So let's name it as a spam underscore classify dot py file. Okay, so we require some libraries. Let's first import it. From we are going to build a Flask app as a backend. So that's why I'm going to firstly import from Flask. From Flask import Flask comma request model we require to request and API, and again JSONify. Okay, second is import pickle, so we require to load our model. Third is from sklearn dot feature extraction dot text import tfid factorizer. set now import re for text preprocessing. From again import nltk, then again from nltk dot corpus import stopwords. This we required for preprocessing our text. From nltk dot tokenize import word underscore tokenize word from nltk dot tokenize import word underscore tokenize. Okay, now first let's load our tf-idf factorizer. tf-idf underscore factorizer equals to tf-idf factorizer. Now we are going to load our model, that is pickle random forest model. Okay, with open we have name of our model is rm underscore model dot pkl. Read this model with bytes as model underscore file and random forest model equals to pickle dot load model underscore file. Okay, so again we have to define a function that pre-process our text that we have already build our model. With the help of that same pre-processing, we have to create another function with the same pre-processing. So let's create that function. Define pre-process the text underscore text function text, and here also we are going to pass the text. The first operation is text equals to text dot lower, convert it into a lower alphabet, should be lower, and second is removing the HTML tags. So text equals to re dot sub, and we have already did this here, so let's just copy it. Okay, where it is, I think it should be okay. So let's copy this only. Okay, the next step would be tokenization. So tokens equals to word underscore tokenize. We have to pass this text into this. Then we are going to remove punctuation and special characters. Okay, so for that I have to clean underscore tokens. So to clean these tokens equals to word for word in tokens. We have already did this, but just I am creating a one-time function which will be process the whole text at a time. Word for word in a tokens if word dot is alphanumeric. Okay, the next pre-processing is remove the stop words that's for that we have to load the stop words. Set stop words dot words, stop word dot words. Again, you have to pass the English. Okay, and the filter tokens underscore tokens equals to word for word in tokens if not in stop words. Okay, so this will remove the stop words if it is in our text. Okay, now word for word in tokens not in, if word not in stop words. The last pre-processing is stemming. So we have to load our porter streamer. PS equals to porter streamer streamer porter streamer, and the stem underscore tokens equals to ps dot stem the word. This will retrieve the root word from the original word. Okay, retrieve the root word from the text we have passed to it. Okay, for word in filtered tokens. Okay, porter streamer, and let's return the clean text, clean underscore text. We have to join this text because all this text is in the token format. So for that I'm going to perform join operation. So dot join the stream tokens. Okay, now return this clean text, return this clean text. Okay, this is our function which will pre-process the whole text and return our clean text. Okay, so now we are going to create an API endpoint with the help of Flask. So for that I have to load the app equals to Flask is an class from the Flask package. Flask, I have to load this class. Okay, name underscore underscore. Now we can write the API endpoint app.route. So endpoint would be /predict. It is the post API. So methods equals to, let's give it space, method equals to post. Okay, let's define function predict. We are not going to pass any argument. So firstly we are going to read the message. So for that we are going to use a request library, request.json. This is the message. Okay, again we are going to pre-process our text. Goes to pre-process text. We are going to pass this message into this. Second part is like we are going to convert this text into a number format, that is numerical format. Vector underscore vectorized message, we can say, underscore message equals to tfid vectorizer. Let's copy this name, tfid vectorizer equals to no, not equals to, dot transform or fit underscore transform We have to pass here the preprocessed text. Okay, and last part is model prediction. Prediction would be equals to this is our model rm underscore model. So let's copy this name. So model dot predict the vectorizer message. So and we have to return the response. So we have to pass like JSONify, return the return JSONify. So I'm going to return a dict, that is prediction, and its value would be our response prediction. Okay, this is our API endpoint. We are going to run this application on the specific port. For that, we have to write if underscore underscore name equals to main underscore underscore main. We have to run our app underscore run. The host would be my machine, host equals to 0.0.0.0, that is localhost, and port would be, let's say, 5000, and let's pass debug equals to true. Okay, so this is our API endpoint. This is our API endpoint. We have written this function and calling it is here. So let's create another file, streamlit.py file. With the help of Streamlit, we are going to create an front end or an user interface. So streamlit.py. Okay, so in Streamlit, with the help of Streamlit, we are going to create a very basic or Python based user interface. So with the help of this user interface, we are going to call our API endpoint. Okay, so for this, first of all, we are going to import Streamlit as st. Okay, again we are going to import request library, which we required for our API endpoint, to call our API endpoint. Actually, let's define a function main. Within this function, we are going to write st. We are going to provide a title to our application is st dot title is an SMS, or we can also say email, because when we pass the email text, it will get classified into an spam or not spam. So we can use this app also for the email classification. So let's write slash email spam and ham classification app. It's just a name. Okay, so now we have to create a button. If st dot button, this will send and request to the API endpoint. For this, we have to first read the data equals to the message, and the message is the user input. So I think we haven't defined the user input. Okay, let's first define the user input. User underscore input equals to st dot text underscore input, and let's write here enter some data. Okay, So now message would be an user input. Okay. Now we are going to hit our API endpoint with the help of this user input. So for that we use request library, request dot post request. This is the post request, and our API endpoint is like http colon slash slash localhost, because we are running our app on the localhost. Okay, so that's why I have already specified the port as a 5000, and the API endpoint is slash predict. Okay, and we are going to pass JSON equals to this data. So this is the data we are going to pass as a JSON. I have provide here localhost and the port 5000, and the slash predict is our API endpoint, because here you can see our API endpoint name is slash predict, and we are running this app on the localhost 0.0.0 is our localhost. We can also mention it here a localhost, and the port is 5000. Okay, so we are running, or we are going to hit this backend app or backend API with the help of this URL. Okay, this will return and response. So if response dot status code equals to 200, then the result equals to response dot text, and if not, then else. In the else part we are going to mention sj dot error, some error occur in backend, occur in backend. Okay, here I have to pass the response st dot success uh, the API response, let's say output equals to this result. Okay, so this is our Streamlit app. So here I can see the response would be written as a success. If it is there is that any error in the backend, then it will return an error message, some error in the backend. To run this Streamlit app, we have to pass here if underscore name underscore equals to underscore main. Okay, so inside this we have to pass our main function main. Okay, so I'm going to pass this main function inside this. Okay, again there is a typo mistake here. It is not a capital S, it's a small s. Okay, st dot success. Okay, so let's save this file. Now let's move on to the our backend part. I think the port streamer is not defined. Okay, we have already imported it in our classification part. So let's copy this line port streamer and paste it here. So this is our backend file. Okay, I think this is also an issue. Clean underscore token is not getting called somewhere anywhere. So okay, I have already passed here token only, so I have to pass clean underscore token. Okay, so I think it's fine. So I have to run this. So let's open our terminal. First of all, we are going to run our backend file, that is spam underscore classify.py file. So let's run this python spam underscore classify.py. So it is running on 5000 port. Here you can see I have already passed here host, the localhost, and port is 5000. Let's open another shell where we are going to run our Streamlit app. That is our front end. So for running Streamlit, we have to write Streamlit run and the file name streamlit.py. Okay, Streamlit. It's not a stream, it's a Streamlit. So Streamlit run streamlit.py. Okay, the file does not exist, I think. Okay, there is a name mistake. It's a Streamlit. I have made some mistake in the file name. I have write it as a Streamlit. That's why there is an error. So let's run this. Okay, so this is our app. We are ready with our app, Streamlit app. So let's write some message. This is the big offer for you. Let's check what would be the output. Okay, there is an some error in the backend. So let's check what is the error. I think in the backend file there is an error. Cannot access local variable preprocess underscore text where it is not associated with a value. Okay, let's check what is happening here. Okay, I have passed variable name as a preprocess underscore text because this is the actual function name. Preprocess underscore text is a function name, and I have also given by mistake the variable name as a preprocess underscore text. So let's change this. I will say processed text, and I'm going to pass it here. Okay, it's fine now. Okay, I think we have to call the TF-IDF factorizer, but we have called it directly. This is, I think, a wrong way. So let's remove this. We'll save the TF-IDF factorizer from our original spam, original training pipeline. So we have used factorizer here. I will show you where it is. Okay, we have used factorize equals to tf-idf factorizer. We are going to save this file as a pickle file. As we have save already our model, we are going to save tf-idf factorizer model in the same way. So let's save with the help of pickle. So let's copy this. I'm going to change only the model name. So by let's remove this rm underscore model. I'm going to pass here vectorizer because I have named that particular tf-idf factorizer as vectorizer. Here you can see where it is. Yeah. So I have named it as a vectorizer. The tf-idf factorizer name is vectorizer. So the model name is vectorizer. Let's name it as a tf-idf underscore factorizer. If we are directly going to use the tf-idf factorizer from the inbuilt package, there will be an issue because we have already used its tf-idf factorizer. So let's make it a pickle file. So I'm going to run this. Okay, pickle. Let's load this. Import pickle. I think the kernel get restarted that, so I have to run this again. Let's run this. It will take little bit amount of time. Okay. It will just take a little bit amount of time. Okay. Okay. So I'm going to run this also. Now we are going to write our tf-idf factorizer into tf-idf factorizer dot pickle file. So let's run this. Here you can see we are ready with tf-idf factorizer. So we are going to call this tape ID factorizer as like we have called the random forest model or random forest classifier. uh, okay, let's change the name of model tf idf underscore factorizer. It's an printing mistake. tf idf underscore factorizer dot pickle, and let's load it as a tf idf factorizer. Okay, now it's fine. We are going to call this in the API endpoint. Here you can see tf factorizer dot transform, and inside this I have to pass process text. So I think we have to pass process text in the list format. Okay. Now our file is backend file is ready to run. So let's run this. Mhm. I think we have already run it, so no need to run it again. Uh, the backend file is getting reloaded because we have already provided debug in this equals to true. That's why it automatically loaded itself as we change something in that particular file. So here it is already getting loaded. So let's open our app. Mm, let's send a message. I think again there is an error. Let's see what is an error. Local variable stop words. Okay, there is an issue. Okay, I have already loaded stop words and also given the name variable name as a stop words. So there is an conflict between them. So let's rename it as a stop words underscore list, and again I have to pass here stop words underscore list because we are on this line. We are going to filter the text and removing all the stop words. So that's why I have passed here if word not in the stop word list. Okay, I have just renamed that particular stop word variable with the stop words underscore list. Okay, so let's save this. Here you can see our file is getting reloaded. Here you can see. Okay, so let's run our app again. I think this time it should work. Okay, it is working fine. Our output prediction is ham. So this is the quite usual message. It is not an offer message or a fake message. That's why it's not a spam. I already created some messages, spam messages. So I have copied it here. So these are the spam messages. So let's copy one out of it. This is the message. You have an overdue tax refund of $1,000 waiting to be claimed. Click the link below to get started now. Okay, so this is the message. I have copied it from somewhere. This is the spam message. So let's pass this into our app. Let's see what will happen. Okay, this time our model or our app says this is an spam SMS. Okay, so there is another message also. Attention mobile users, own your device for over 11 months. You qualify for a complimentary upgrade to the latest color mobiles with cameras. Get some extra complimentary device for us. Let's copy this and pass it to our app. Firstly, let's remove this and pass the new message. Again, let's see what is our okay. The model says or the app says our prediction is a spam. Our SMS is a spam SMS. Okay, so I think it's overall a good uh, project to add it in your resume. So I think there should not be any change. All is working fine because our app is working fine. Okay, I have named it as a SMS and email spam, and email spam and ham classification app, because whenever we are going to pass an email to this app, it handle it as like a same as like a SMS. Okay, so that's why there is not an issue when we pass an email to this. It will definitely will detect it is a spam or ham. Okay, so that's why I have named it as a SMS slash email spam and ham classification app. In our future journey, we are going to build such kind of projects, or many projects we can say. So the projects may be from different domain, like object detection, image classification, large language modeling, or anything. We are going to create a project with end-to-end deployment. We are going to deploy it with Streamlit, or there are another ways to deploy. So we are going to also apply those ways to deploy our application. So thank you for your time. Please subscribe my YouTube channel. Your support means a lot for me. See you in the next exciting video.